In this video, I'd be talking about merge sort. The design algorithm followed for merge sort is divide and conquer, which involves three steps: dividing, conquering, and combining. Given a problem, you'd be dividing the problem into a series of subproblems, and each subproblem is conquered, that is solved, using the same approach. And then finally, you combine all the results of the subproblems to find the result of the main problem. Okay, so this is the algorithm for merge sort. Okay, in merge sort, the merge sort function takes three parameters: the array to be sorted, the starting index, and the end index. Okay, so if this were to be the array that I'm trying to sort, and if this is the initial call, this is what happens. Well, 1 and 8, so 1 less than 8 true, and q would be 4. 1 plus 8 by 2, 4, and there would be two function calls within so these ones. So the first call would be merge sort on a 1 comma 4. The next one is merge sort on a 5 8, and finally merge. Okay. So this call, so when control comes to this call, it would further call merge sort on a 1 comma 2, because 1 comma 4 is passed to PNR. So 1 less than 4 true, 1 plus 4 by 2, that is 5 by 2, which is 2. So q is 2. So these two calls would be made. Okay, so this is the sequence of flow. This was the initial call you made. So this would call, this would execute this piece of code. Okay, and this is the first function to be executed. Okay, and then which in turn calls the same function on with different parameters, 1 comma 4, and which in turn invokes these two functions, or these three. Okay, but before that, this itself invokes these ones here, and this invokes. So let's see. So a 1 comma 2 is further makes a call to a 1 comma 1 and a 2 comma 2. So a 1 comma 1 has 5 in it, so that's 1, and a 2 comma 2, that is a 2, has 2 in it. When you merge, you'd be ending up with 2 and 5 in a 1 and 2. So similarly, so after this call is done, after merge is done, it returns back to this call, and then followed by the execution of this one here, which in turn calls 3 comma 3. Now in this case, a3 has, well, 4 in it, so that's 4 in a3, and 4 has 7 in it. So when you merge 3 and 4, you got 4 and 7, and then you return the call. After this, you return the call to this, which now merge is executed on 1 to 4. So when you merge, a would have so you're actually merging 1 2, which is 2 5, and 4 7. You'd be having 2 4 5 7, 1 2 3 4, right? So because you're merging from 1 to 4, if you look at the contents of a 1 2 3 4, after the return, you have 2 5, and you have 4 7. So you're merging these two sub arrays, right, at this point. So when you merge these two sub arrays, you'd be getting 2 4 5 7, which is a sorted sub array. now the call returns. So after merging, the call returns to the end of this. Now this is executed. Now this in turn invokes a chain of calls, 5 6 right, and then so this in turn invokes 5. So at 5 I have 1, so that's 1, and at 6 I have 3. So when I merge in A 5 and 6, I have 1 comma 3, right? So this is returned. Now this is executed, which invokes these set of calls, and A7 A8 I have 2 6. So at 7 I have 2, at 8 I have 6, and I merge. So I have at 7 8 I have 2 6, and this returns to merge. So at merge I'm merging 5 through 8. So which is, if I were to write down the contents, from 5 through 8 I have 1 3, which is this one, and I have 2 6, right, which is this one. It's 2 6 and 1 3. Now when I merge from 5 through 8 with this as my center point, I mean at 6, I'd be looking at 1 3 and 2 6, and I'd be sorting them 5 through 8. So that would be, so my A from 5 6 7 8, when you're merging at this point, is 1 2 3 6. Okay, so you have now the contents of A are 2 5 4 7 from this part, from that part, and 1 2 3 6 from this part, 2 3 6 at 5 6 7 8 from this part. Okay, now after executing merge, the control returns to the end of this, and it invokes merge again, but this time from 1 through 8 with 4 as the center. Okay, so right there. So when you merge these two, obviously you'd be ending up with a sorted array. So 1 2 2 3 4 5 6 7, 1 2 3 4 5 6 7 8. There you go, it's sorted now. Alright, so how do you analyze such kind of divide and conquer algorithms? Now suppose that our design of the problem yields yes problems, now which each one of which is 1 by b, the original size. Now how do you analyze it? If you take d of n to Okay, so if you take d of n to divide the problem into subproblems, okay, so you have a problem, you have a size n, and then you divide this into a subproblems with the size of each is 1 over b, the original size. Okay, so the time taken to solve for okay, so say in order to divide the original problem of say size n, you take dn, and then in order to combine the subproblems into n again, you take time cn. Okay, now you have several subproblems. Now the time taken for n could be represented as the time taken to divide it, right, into several subproblems, as well as combine the subproblems to, so that is combined to combine back to n, right, plus the time taken for each subproblem, right, or the total number of subproblems. So that is a into t n by b plus d of n plus c of n, which is this. So the time taken to solve a problem of size n is nothing but the sum of the time taken to divide it into a subproblems of size 1 by b of the whole size, plus the time taken to combine the subproblems into back to the same problem, okay, and the time taken to solve all the subproblems. Okay, so the time taken to solve the big one is the time taken to solve each small one, plus the time taken to divide it and combine all the small ones back to this. In case of merge sort, this is what it is. We are dividing that into two equal subarrays. That is two subarrays of the same size. In conquering, we are further dividing that to subhalves, and then we are combining or we are merging to produce the result. So the running time of merge sort could be represented in this following recurrence equation. So that is a is 2. That is, I've divided my problem to two halves. So 2 half the original size of the problem, plus d of n. So time taken to divide is a constant time, so that could be ignored, and time taken to combine it, which is the merging part, is done in theta of n. Okay, and this is a constant time. Now this could be proven to be theta of n log n. Let's see how. So say, okay, this is what the merge sort is, right? Okay, you start off with Tn, so you say T of n is Cn plus 2Tn by 2, so Tn by 2 and Tn by 2. Now each one would further give me, so what is Tn by 2? That is 2Tn by 4 plus Cn by 2. Cn by 2. So if you were to write that down, you'll have Cn, right? So Tn by 2 is Cn by 2, Cn by 2, which is given here, right? Cn, oopsie, sorry. So well, Tn is Cn plus 2n by 2, 2Tn by 2, so Tn by 2, Tn by 2, but Tn by 2 itself is this. Okay, so if I expand this, I get Cn is Tn by 2 is Cn by 2 plus 2n by 4, Cn by 2, Tn by 4, Tn by 4, and so on, right? And then say if n is 4, this one would be 4 by 4 T of 1, which is C, so each one of this would be C, right? And if you were to add up, so this is Cn and this is Cn, this would add up to n times C, right? Because if n is 4, this would be 1, 2, 3, 4 times. So if you were to add all of these together, you would get Cn plus log n Cn. If you rearrange it, then you would know it's theta of n log n. Now let's take a look at how we merge. Say if you were to start off with an initial array 2, 4, 5, 7, 1, 2, 3, 6, you basically split that in half, okay, and then you take 2, 4, 5, 7 in one array, and 1, 1, 2, 3, 6 in another, and then you do comparison. You'd compare 2 and 1. So now because 1 is smaller than 2, you'd put 1 here, okay. So and then you move the pointer here. This is still there. Now 2 and 2 equal, right? And then say you move here. Now 4 and 2, 2, right? And then you move this here. Now 3 and 4, 3. You move this here. Now 6 and 4, 4, right? And then 6 and 5, and you move here. And then 6 and 5, it's 5, and you move here. 6 and 7, 6. This is the end of it. Copy the remaining into this array. So that's how you merge. So this would be the content of the new array now. And this takes, because you're iterating through the whole array once, it takes theta of n. So that's the reason why you have considered the merge time to be theta of n.